At the edge of all we understand lies a question that refuses to stay silent. How can a universe without walls, borders, or boundaries still draw a line we can never cross? It is a contradiction that hums beneath every star we chart, every galaxy we name, every distant whisper NASA pulls out of the darkness. Because no matter how far our machines reach, the light they gather comes from a horizon that recedes as fast as we chase it. A limit stitched not into the universe itself, but into our ability to see. Yet the mystery deepens. If the cosmos has no physical edge, then what is this boundary we keep colliding with? What lives just beyond the last photon that will ever reach us? NASA's telescopes aim into that silence like instruments tuning the void, listening for something that might break the rules we thought were unbreakable. But each discovery only widens the paradox. The universe expands, our sight stretches, and still a frontier remains. We stand in that tension, suspended between nothing and everything, knowing that all we understand must someday confront what we cannot. And yet, everything we know ends somewhere. In the beginning, before stars learned to burn, and before galaxies learned to gather, the universe held a secret that would one day unsettle every mind that dared to imagine it. A secret so simple it feels impossible. The universe has no edges. There are no walls surrounding existence, no cosmic cliff, no final barrier where light goes to die. And yet, impossibly, undeniably, there is an edge to what we can see. We live inside a boundless reality that somehow presents us with a boundary. A contradiction carved into the fabric of everything, like a silent riddle waiting for someone to notice. At first glance, the paradox feels harmless, almost poetic. But the moment you sit still with it, the ground shifts. Because every horizon we have ever known, our seas, our lands, even our personal limits, has been something physical, something concrete. But the cosmic horizon, it is not a wall. It is a story written in the language of light and time. And NASA, through its telescopes and instruments, has become the translator of that story. Each mission becomes a breath drawn deeper into the unknown. Each lens a doorway into the past. And slowly, through images older than civilization itself, we begin to understand that the cosmos we inhabit is stranger than anything imagination could invent. We often picture the universe as a vast black sphere expanding into emptiness. But that image is a lie told by instinct. The universe is not expanding into anything. Space itself stretches, like a living fabric pulling every thread slightly farther from every other. There is no outside to expand into and no edge to expand from. The universe is all there is, and whatever it becomes within itself. Yet paradoxically, the farther NASA looks, the more it seems that this infinite expanse has drawn a circle around our vision, a limit, a delicate horizon of about 46 billion light-years in every direction, the observable universe, a sphere not imposed by nature but by time. Light travels at a finite speed, and the universe has only existed for 13.8 billion years. So, we can see only as far as light has had time to reach us. That means the edge is not a place. It is a moment, a boundary made of time rather than space, written by the fact that the early universe was too young to shine. Before stars lit their first fires, before atoms even settled into stable form, the cosmos was a fog, opaque, blisteringly hot, refusing to reveal itself. When NASA peers beyond galaxies, past the star clusters and nebulae, it eventually reaches that moment, the last scattering surface, the oldest light, the horizon of knowability. But beyond that horizon, the universe continues, smoothly, seamlessly, without borders, a reality where distance and direction lose meaning because space is curved, perhaps even wrapped around itself, like a four-dimensional loop. Some cosmologists imagine the universe as a cosmic balloon, not because there's air inside, but because the surface of a balloon has no edges, no center on the surface, and yet it expands. Others see it as a saddle, a universe with negative curvature, open and endless. Still others propose shapes more abstract, topologies that twist in ways we cannot draw, but can only describe mathematically. Whatever its true form, one truth remains unshaken. The universe offers no physical edge to touch, and yet our sight ends. NASA's telescopes turn that contradiction into a journey. When the James Webb Space Telescope gathers the faint glow of galaxies formed just a few 100 million years after the Big Bang, it is not just photographing distant worlds. It is catching ancient light, photons that began their flight before Earth existed, before the Sun existed, before even the Milky Way was a thought in the cosmic mind. Each image is a time capsule, a revelation, a reminder that space is not merely distance. It is history stretched outward. And the deeper we look, the more that history pushes back. But even as we map that history, the disorientation grows. How can something have no edges, yet contain an edge of visibility? How can infinity leave us with a hard stop? The answer lies in the expansion of space itself. As the universe grew, distant regions raced away from us faster than their light could ever hope to catch up. Some regions accelerate beyond reach forever, not because they are behind a wall, but because space between us and them expands too quickly. In this sense, the universe behaves like a dream in motion, always expanding, always stretching, always slipping slightly beyond the edges of comprehension. This creates a strange duality. The universe we can see is finite. The universe that exists may be infinite. We live inside a sphere of information bounded not by physics, but by possibility. And as NASA sharpens its vision, building bigger mirrors, colder detectors, more sensitive infrared eyes, our sphere widens, but only by a little. No matter how advanced our technology becomes, there will always remain a veil we cannot pierce, a distance from which no signal can ever reach us, a place where reality continues silently without us. And this brings a deeper question, one that cosmology cannot answer, but philosophy cannot ignore. If a boundless universe contains a boundary of perception, what does that mean for our relationship to reality? We often assume that what we see is what exists. But at the cosmic scale, what we see is merely what we can see. The universe beyond the horizon may be unimaginably vast. It may contain structures grander than any galaxy we've discovered, or emptiness more profound than anything we fear. It may mirror our universe or diverge from it entirely. It may be familiar, or it may be forever alien. We simply cannot know. Yet we still try, because to look into the cosmos is to challenge the quiet arrogance of human perception. Every new mission reminds us that we are creatures who evolved to navigate rivers, mountains, and the thin layer of atmosphere clinging to a small rocky world. Not to understand creation, not to chart infinity, but somehow, impossibly, we do both. NASA's telescopes turn the sky into a mirror that reflects not just stars, but the audacity of the human spirit. a spirit that insists on knowing what lies beyond, even when the universe itself draws a line we can't cross. But as we chase that knowledge, something unexpected begins to happen. The more we understand the universe's geometry, the more its strangeness becomes a kind of clarity. A universe without edges is not incomplete. It is whole, self-contained, free of boundaries because boundaries are a human invention, born from a world where edges matter. But the cosmos doesn't care for walls. It expands evenly, endlessly, like an idea unfolding in every direction. And the observable edge, the limit of light and time, is simply the part of that idea we have access to. Still, the contradiction refuses to let go. Because deep down, we feel that if something has an edge of visibility, then somewhere out there must be an end. A border, a final frontier waiting to be found. Our instincts cling to the notion that everything must have a shape, a form, a limit. But the universe challenges that belief. It challenges the very structure of thought. It reminds us that the world we evolved to understand is not the world we inhabit. And so we move backward through time, peeling away the layers of cosmic history, past the modern universe with its webs of galaxies, past the early universe where matter had barely learned to assemble itself, past the primordial plasma, where quarks and electrons drifted in blinding heat, and finally, to the first instant, when space itself erupted from a state we cannot name, cannot fathom, cannot truly imagine. That moment wasn't a point inside the universe. It was the beginning of the universe. A creation with no center and no edge, expanding equally everywhere. This is the truth we return to again and again. The universe is borderless, but our understanding is not. And the edge we see is not the universe's limit. It is the limit of our light, our time, our reach. But a question lingers in the silence between facts and wonder. A question that pulls us deeper into the story, deeper into the mystery, deeper into the confrontation with everything we still don't know. If the universe has no edge, why does our vision stop? Long before humanity gave names to the stars, before we learned to measure distance or bend mathematics around the shape of the cosmos, light had already begun its long journey toward us. Every photon that touches our eyes today carries a memory. And together, those memories reveal a truth so profound it reshapes our sense of existence. We live inside a bubble. Not a bubble of matter or structure, but of visibility. A cosmic horizon. A wall made not of stone or boundary, but of time itself. And as NASA's instruments reach deeper into the dark, that horizon becomes more than a concept. It becomes a revelation. Because when we look out into the universe, we are not seeing space as it is. We are seeing space as it was. The farther we look, the older the light becomes. A galaxy 1 billion light years away shows us a story 1 billion years old. A galaxy 10 billion light years away reveals a universe still in its adolescence. And the faintest, most ancient whisper, the cosmic microwave background, transports us to a time when the cosmos was only 380,000 years old, a newborn creation wrapped in fire. The cosmic horizon forms at the very edge of that light. Beyond it lies darkness, not because nothing exists there, but because light from those regions has not had enough time to reach us. The universe is expanding, stretching faster than photons can cross its widening distances, and so an invisible wall appears, encasing us gently but firmly within a sphere of the knowable. a finite window into an infinite world, a limit written not by the universe itself, but by the clock that began ticking the moment everything began. This is why NASA's greatest telescopes behave like time machines. The James Webb Space Telescope does not merely look across distance, it looks across eras. When Webb captures galaxies formed just after the first stars ignited, it unveils chapters of the cosmic story written long before Earth was dust in the dark. Those galaxies appear small, bright, and strangely compressed, stretched by the weight of cosmic time. Their light has traveled through an expanding ocean of space-time, its wavelength pulled like a slow breath into longer, redder tones. Redshift, a cosmic fingerprint of expansion, a signature of motion written into the color of the universe. But redshift is also a warning. The more space stretches, the more the light loses energy, and the fainter it becomes. Some galaxies are now so far away that their light can never reach us, no matter how long the universe lasts. They slip beyond the cosmic horizon, drifting into eternal invisibility. We share a universe with countless regions we will never observe, never map, never even imagine. Yet they are as real as our own, continuing their silent evolution across distances that grow faster than information can cross them. To understand this strange imprisonment, we follow NASA's eyes back to the oldest light of all, the cosmic microwave background. This faint glow, discovered accidentally in the 1960s and later mapped in exquisite detail by NASA's SCOBY, WMAP, and Planck missions, is the afterglow of the Big Bang. Not a fireball, but a cooled, stretched remnant of light that once filled the universe with blinding brilliance. At the moment this light was released, the universe became transparent. Atoms formed. Darkness finally had a chance to exist, and those photons began traveling outward, carrying with them the imprint of the universe's first breath. Today, we detect them as microwaves, cold, soft, nearly uniform radiation coming from every direction. But encoded within that uniformity are tiny ripples, imperfections, temperature variations no stronger than a whisper, yet powerful enough to seed all structure that would one day form. These ripples became galaxies. The galaxies became clusters. The clusters became the vast cosmic web. And we somehow became witnesses to it all. But the cosmic microwave background also reveals something deeper, the exact shape of our cosmic horizon. It is the ultimate boundary of sight, the curtain beyond which the universe remains forever hidden. Not because it ends there, but because the early universe was too dense for light to escape. Before the cosmic microwave background, photons bounced between particles like restless prisoners, unable to travel freely. Space was an opaque storm. No telescope, no matter how powerful, can see beyond that era. Light from earlier times simply does not exist. And so the horizon stands, a wall built from the absence of light. A reminder that our knowledge begins at a surface of ancient fire and ends at a silence we cannot penetrate. As NASA mapped that surface with greater precision, something remarkable happened. The horizon began to take shape as a nearly perfect sphere around us. Not because Earth holds a privileged position, it doesn't, but because the horizon forms around every observer, everywhere, in every direction. Every galaxy has its own cosmic bubble. Every corner of space sees itself as the center of its observable universe. And this symmetry reveals a strange, humbling truth. The horizon is not about where we are. It's about when we are. Time becomes the architecture of visibility. Light becomes the storyteller, and space becomes the stage on which those stories travel. But what lies beyond this stage? What exists outside the boundaries of what we can ever see? The laws of physics suggest that the universe extends far beyond our horizon, perhaps infinitely, perhaps only unimaginably far. It may hold galaxies that form differently, stars that burn in unfamiliar ways, regions shaped by quantum fluctuations long erased from our view. Entire cosmic webs could stretch across distances forever forbidden to us. And yet, our horizon remains the seal that separates the known from the unknowable. This realization is unsettling. It forces us to confront the fragile nature of human understanding. We are creatures who evolved to track prey across grasslands, to navigate rivers, to mark the passing of seasons. Yet here we are, deciphering messages older than Earth itself, staring into horizons that weren't made for us. We have built tools capable of catching the faintest echoes of creation. And still, the universe whispers that we will never see it all. But instead of despair, there is awe, because within that limitation lies a profound beauty. The cosmic horizon does not imprison us. It defines the grandeur of the universe we inhabit. It shows us that existence is larger than comprehension, that reality is deeper than perception, that our bubble of visibility is not a cage but a window, and it is up to us to keep looking through it. Philosophically, this horizon asks a quieter question. What does it mean to live inside a sphere of perception? If every creature in the universe, on every distant world, sees itself at the center of its own observable cosmos, then, perhaps, the universe is telling us something subtle. That perspective shapes reality. That the limits of sight are not failures, but frames. That meaning arises not from seeing everything, but from understanding that there is always more than can be seen. Still, the scientific implications remain staggering, because the horizon is not fixed, it grows. With each passing moment, more light reaches us from previously hidden regions. Our bubble expands, slowly revealing more of the universe's distant past. But even as one horizon grows, another remains forever out of reach. Some galaxies recede faster than light can chase them. Their stories will never arrive. Their light will never touch us. They belong to another cosmic narrative, unfold too quickly for us to witness. This duality, expansion granting sight while simultaneously denying sight, creates a tension that NASA's missions navigate with precision and wonder. Every new telescope widens our understanding, yet also sharpens the boundary of the unknowable. The horizon becomes both invitation and refusal, a doorway that opens only in one direction, backward in time, never outward in space. And as NASA peers deeper into that ancient light, the horizon reveals more than just the universe's first moments. It reveals clues, subtle, delicate anomalies that hint at something unexpected, something unaccounted for, something that doesn't quite fit the neat equations we've built to explain everything. Because when we map the cosmic microwave background with exquisite detail, we expected smoothness, symmetry, simplicity. But the universe had left her fingerprints, imperfections, asymmetries, regions slightly too warm, others slightly too cold, alignments that should not exist, patterns that feel like the first cracks in a perfect cosmic story. The horizon was not merely a boundary, it was a message, a whisper, A clue. And NASA saw more than just ancient light. It saw the first cracks in our understanding. For most of modern cosmology, the early universe was supposed to be simple, small, unstructured, a cosmic infant taking its first trembling steps into existence. For decades, astronomers believed that the first few 100 million years after the Big Bang were a quiet darkness, a slow gathering of matter too gentle to form anything remarkable. Stars should have been rare. Galaxies should have been tiny. Black holes should have been almost non-existent. The universe, we thought, had to learn how to build before it could create anything grand. But then NASA sent a new set of eyes into the void. Eyes sharper than any before them. Eyes capable of catching the faintest shimmer of starlight from the dawn of time. The James Webb Space Telescope did not simply extend our reach. It shattered our predictions. It looked farther than any instrument had ever looked, and what it found did not belong to the universe we thought we understood. The calm fabric of cosmological theory began to tremble. Because the earliest galaxies JWST detected were not small or fragile. They were giants, fully formed, rotating, packed with stars far too bright, far too massive, far too numerous for their age. Some appeared only 300 million years after the Big Bang, an instant, cosmically speaking. And yet they shone with the luminosity of mature systems billions of years old. It was like finding a sprawling metropolis in a world where cities were not supposed to exist. At first, astronomers blinked, recalibrated, searched for errors, but the signals did not fade. The data held. The impossible became real. These galaxies were not just unexpected. They were impossible under the rules we had written. The early universe should not have had enough time to pool matter together with this much speed. Gas clouds should not have collapsed fast enough. Stars should not have assembled in such numbers. Gravity should have been too weak. And yet the light from these objects, stretched across billions of years of expanding space, reached JWST with the quiet confidence, as if whispering, "You have underestimated creation." But the shock did not stop there. When NASA looked deeper, it found black holes, supermassive ones, lurking in these early structures. Not the small seeds we expected, not the gradual growth predicted by our models, but titans millions, even billions of times the mass of the Sun. Their sheer size defied the timelines of cosmic evolution. Under our best theories, such monsters should have taken billions of years to form. And yet here they were, roaring at the edge of time, already ancient before the universe had fully awakened. It made no sense. Black holes of this scale require either absurdly fast growth or a beginning even more mysterious than the universe itself. Some scientists proposed exotic scenarios: direct collapse black holes, primordial overdensities, or unknown processes in the early cosmos that turbocharged gravity. Others whispered darker possibilities. Maybe the universe was not as uniform as we believed. Maybe the seeds of chaos were planted early, hidden behind the cosmic horizon until NASA's newest eyes could reveal them. Still, JWST kept digging. The more it saw, the more the story unraveled. Galaxies clustered together earlier than physics allowed. Massive structures appeared too soon. Enormous filaments, strands of matter tens of millions of light years long, seemed to exist before cosmic expansion should have permitted such organization. In the early universe, everything should have been smooth and evenly distributed. There should have been no time for gravity to sculpt such intricate patterns. And yet the patterns were there, written clearly in the ancient light. The cosmos was not waiting patiently to grow. It was rushing, accelerating, assembling itself with a kind of fierce urgency, as though something in those first moments was pulling the universe into shape faster than we imagined, as though the laws we trusted did not apply uniformly across time. One discovery in particular sent an almost physical shiver through the scientific community: galaxies that appeared denser than any we have today. Galactic cores stuffed with stars so tightly packed they resembled cosmic furnaces. Some glowed with a light so intense that if you could approach one, though no human could survive the radiation, the sky would appear almost solid with starlight. These were not gentle beginnings. They were cosmic overachievers, reality-breaking engines of creation. Calm explanations faltered. Something didn't add up. As JWST continued its sweep across the earliest epochs, it found more anomalies. Galaxies with complex shapes, spirals and disks forming far too early. Structures that defied the slow, hierarchical growth model that had dominated cosmology for decades. The universe, it seemed, did not evolve gradually. It erupted into complexity with a speed that bordered on violent. What we once imagined as a peaceful dawn now resembled a cosmic storm. But perhaps the most unsettling discoveries were the ones that didn't seem impossible at the first glance, only strange. Small inconsistencies, patterns in the distribution of galaxies, slight deviations in expected brightness, odd alignments across vast distances. Together, these formed a whisper beneath the data. The early universe might have been influenced by something we could not see, something beyond the horizon, something tugging at matter from a place no telescope could observe. This idea was not new. For years, some cosmologists suspected that large-scale anomalies, like the mysterious dark flow, a motion of galaxy clusters toward an unseen direction, hinted at influences outside the observable universe. But JWST lent new weight to these suspicions. If galaxies were forming too fast, too large, too structured, then either the initial conditions of the universe were wildly different from what we believed, or something beyond our horizon was shaping what happened within it. Imagine the early universe as a vast ocean of potential. Gravity, temperature, and density working together in delicate balance. Now, imagine a hand, faint and immeasurable, pressing gently against the fabric from the outside. Not enough to tear it. Not enough to break the laws of physics. Just enough to tilt the scales. Just enough to seed structures where none should exist. It sounds impossible. But then again, so did the galaxies JWST found. Every new observation chipped away at the calm stability of cosmological theory. What once felt solid began to wobble. Standard models strained under the weight of data they were never built to explain. It was not chaos in the sense of destruction. It was chaos in the sense of revelation. A reminder that the universe is not obligated to behave according to the rules we write for it. Amid this growing tension, one idea became harder to ignore. Perhaps our understanding of time in the early universe is incomplete. Perhaps the rate of expansion was different in ways we haven't accounted for. Perhaps quantum fluctuations inflated not just space, but complexity itself. Or perhaps, in the most unsettling possibility of all, the observable universe is only a piece of a larger structure, And what we see as anomalies are merely shadows cast by a reality beyond our reach. Calm explanations began breaking down. Even scientists who had spent careers refining cosmological models found themselves staring at data that felt like a quiet accusation. You assumed too much. You understood too little. And through it all, JWS remained silent. It did not argue. It did not theorize. It simply gathered light, ancient light, and allowed humanity to confront its implications. Some of the earliest galaxies appeared almost tauntingly ordinary. Spirals, disks, star nurseries, features that should have taken billions of years to sculpt. They spun with a grace the early cosmos had no right to possess. They matured before the universe had time to draw its first full breath. It was as if nature had skipped chapters in its own story. Even more unsettling were the voids, vast empty regions existing beside these oversized galaxies. Voids require time to carve, time for matter to flow outward, time for structures to form. But these voids appeared too soon, their presence echoing a question we were not yet ready to answer. The early universe was not chaotic in the way chaos shatters order. It was chaotic in the way order emerges too quickly, like a puzzle assembling itself while the pieces are still being created. And so, tension builds. The calm narrative of cosmic evolution warps under the gravity of new discoveries. The expected becomes uncertain. The familiar bends toward the uncanny. Something about the early universe feels influenced, as if its structure was pulled taut by forces we cannot observe. We return to the light, to the quiet glow that has traveled 13 billion years just to confuse us. We look again at the impossible galaxies, the overgrown black holes, the megastructures too large for their age. We listen to the silent hum of the data, and in that hum, we sense the shape of a larger mystery. The universe was building itself too fast, too boldly, too impossibly. Something beyond the horizon was pulling the early universe into impossible shapes. In the grand stillness of the cosmos, where galaxies glide like lanterns on a dark sea, we once believed that everything drifted without preference. No direction mattered more than another. Expansion was uniform. Motion was random. The universe, in its vast impartiality, treated every corner the same. But then NASA found something that broke that comforting symmetry. Something subtle at first, then unmistakable. Something that suggested the universe was being tugged. Not locally, not regionally, but on a scale so enormous it defied imagination. It began with the galaxy clusters, hundreds of them, then thousands, all drifting together, not because of local gravity, not because of mergers or collisions, but as if responding to a distant pull, a cosmic current, a flow, a movement toward a region of space we cannot see, cannot study, cannot ever reach, a direction beyond the observable universe. This became known as dark flow, one of cosmology's most forbidden discoveries, a phenomenon that whispered of forces existing outside our cosmic bubble, bending the motion of galaxy clusters like invisible tides. At first, astronomers dismissed the idea. It sounded too strange, too theatrical. Galaxy clusters, after all, move for many reasons. Gravity from nearby structures, the expansion of space itself. But when NASA's Wilkinson Microwave Anisotropy Probe, WMAP, examined tiny temperature variations in the cosmic microwave background, something unexpected emerged from the data. A dipole pattern, an imprint suggesting that enormous clusters of galaxies were all marching in nearly the same direction. Not slowly, not randomly, purposefully, coherently. The signal was faint but persistent. It didn't fade with new measurements. It didn't scatter with larger samples. Instead, it grew clearer. Something large, something unimaginable, seemed to be pulling on matter across billions of light years. But what could exert such influence? No known structure inside the observable universe was big enough or massive enough to cause it. Not superclusters, not filaments, not even the Great Attractor. A gravitational anomaly already known to tug at the Milky Way. The dark flow was stronger, wider, older. It appeared to originate from a region far beyond the 46 billion light-year boundary of what we can see. That realization struck scientists with equal parts awe and dread. Because if something outside the observable universe had enough gravitational power to move thousands of galaxy clusters, then the cosmos beyond our horizon was not empty. It was not symmetrical. It was not calm. Something out there had weight, influence, presence, and we were feeling its pull. NASA researchers analyzed the data again and again. The pattern held. Galaxy clusters were drifting at speeds up to 600 or 1,000 kilometers per second, fast enough to cross the Milky Way in less than 1,000 years, fast enough to carve their own motion into the cosmic microwave background. This was not a local quirk. It was a cosmic directive. For the first time, humanity faced the possibility that our universe was being shaped by something outside itself. Some proposed that this unseen influence might be a remnant of the universe's earliest moments, a gravitational field frozen into space during inflation, the rapid expansion that erupted fractions of a second after the Big Bang. Others suggested something more dramatic. Perhaps other universes existed beyond our cosmic horizon. Perhaps cosmic inflation created vast regions of space-time, each with its own physics, its own structures, its own colossal masses. And perhaps one of those masses sat just beyond our reach, tugging at us across a boundary we can never cross. It was a hypothesis, both exhilarating and terrifying. If true, the dark flow was not just a quirk of physics. It was a message from the outside. A hint that our universe is only one part of a grander cosmic architecture. A fragment of a much larger reality whose full shape we cannot yet imagine. But controversy soon followed. Some scientists argued that the signal was statistical noise, a misinterpretation of the data. Others insisted it was real, pointing to multiple analyses that detected the same drift. The debate became a quiet storm in the halls of cosmology, a clash between those who clung to the comfort of symmetry and those who stared willingly into the abyss of the unknown. Yet the motion of galaxy clusters remained stubborn. Independent observations continued to hint that something was guiding them. Even as new instruments refined the measurements, the underlying question refused to disappear. What lies beyond the observable universe? And why does it pull on us? If the universe is truly infinite and uniform, then no direction should matter. Every large-scale motion should balance out over time. But dark flow violated that principle. It broke the cosmic symmetry. It whispered that our observable sphere was tilted towards something, or away from something, or overshadowed by something vast beyond imagining. Philosophically, the implications were profound. If forces exist outside our perception, then the boundaries of the observable universe are not the boundaries of reality. Our cosmic horizon becomes not a limit, but a veil, a soft barrier separating what we can measure from what we cannot. The universe we observe becomes a bubble drifting in an ocean of unseen influences. And bubbles, however beautiful, are fragile. The more astronomers studied the motion of galaxy clusters, the more intricate the pattern became. It was not a simple flow. It was not uniform. Some clusters accelerated more than others, as if passing through subtle gravitational gradients. A wave, a current, a tide reshaping itself across time. It was almost poetic. The universe, we realized, moves like water responding to a distant moon, pulled gently, rhythmically, invisibly, by something that remains forever out of sight. But dread followed wonder. Because if something beyond our horizon is tugging at matter within our universe, then the structure of space-time itself may not be isolated. Boundaries may not isolate us as completely as we believed. Gravity may leak across horizons, responding to mass in realms we can never enter. The laws of physics might stretch farther than our observations allow, binding together regions of reality that will never share a photon. And if that is true, then the cosmos is more connected and more haunted than we ever imagined. For years, NASA scientists tried to identify a familiar explanation. Maybe the dark flow was the shadow of a supercluster we couldn't see. Perhaps vast voids created gravitational imbalances that mimicked an external pull. But no internal structure matched the scale or direction of the effect. The flow pointed distinctly outward, toward a region that lay beyond visibility, beyond measurement, beyond time. The CMB dipole, the subtle shift in ancient light caused by our own motion through space, aligned suspiciously close to the direction of the dark flow. It was as if the oldest light in the universe and the largest motions of galaxy clusters were being tugged by the same unseen hand. Coincidence, some said, evidence, others whispered. As controversy grew, so did fascination. The idea that something outside the universe, or beyond the observable portion of it, influenced our cosmic neighborhood became a cultural myth, a scientific riddle, a philosophical provocation. What if the universe was not alone? What if the inflationary multiverse, a vast landscape of other universes, was not merely theory, but something with real gravitational influence? What if our bubble brushed against another in those first explosive microseconds? What if the dark flow was the lingering echo of that collision? These questions were not just scientific speculation. They were existential. Because if something lies beyond the universe we see, shaping the motion of galaxies, then we must reevaluate what everything means. Reality might not be a single story. It might be a library of worlds, each sealed from one another by the speed of light, each occasionally leaving fingerprints on the others. And dark flow may be one such fingerprint. Eventually, some researchers proposed that giant structures, larger than anything we have discovered, existed beyond our horizon. Gigantic clusters or walls of matter, too far away to see yet close enough to exert gravitational influence. If such structures exist, they dwarf anything in the observable universe. They would be the largest objects in all of space-time, and they would remain forever invisible. Nothing in our current models requires such titans to exist, but nothing forbids them either. In this uncertainty, a quiet dread settles. We are not being pulled by a known force. We are being pulled by a question, a mystery, a whisper from the unseen edges of creation. The strangest possibility is also the simplest. The dark flow may be the echo of initial conditions, primordial features imprinted on the universe before light could form. If that is true, then the pull comes not from a distant structure, but from the memory of a time beyond physics. Whatever the explanation, the message remains the same. Something out there is influencing everything in here. We cannot see it, we cannot reach it, we cannot map it. But still, the universe leans toward it, and as NASA continues to collect data, the tension deepens. Dark flow remains unresolved, unexplained, uncomfortably persistent. A reminder that our cosmic horizon is not the end of forces, not the end of structure, not the end of influence. It is only the end of sight. And whatever caused the dark flow might never enter our universe. Yet it leaves fingerprints across everything. What lies beyond the edge of everything we can see? It is a question older than science, older than philosophy, older even than the first human who looked at the night sky and felt the pull of something vast on the other side of thought. For centuries, the boundary of the universe was a place of myth. Then it became a place of mathematics. And now, through NASA's instruments, it is becoming something stranger still. Not a boundary at all, but a clue. A hint that the universe we see is only a fragment of a far grander reality. To understand this, we must go back, farther than the cosmic microwave background, farther than the first stars, farther even than the Big Bang as we normally imagine it. We go to a moment when the universe was not yet a universe, when space itself had not fully decided to exist. A moment ruled not by galaxies or particles, but by pure potential, the quantum landscape. Here begins the story of inflation, a theory that transformed cosmology from a tale of one universe into the possibility of infinite universes. Inflation describes a sudden, explosive expansion of space-time in the tiniest fraction of a second after the beginning. Not a gentle drift, not a smooth unfolding. A violent exponential surge. Space stretching faster than light could ever hope to travel. Distances expanding so quickly that regions of the cosmos were torn apart before they could ever share information. Inflation did more than expand the universe. It fractured reality. It created isolated pockets of space-time, each sealed from the others by expansion that never stopped. Each pocket became its own universe. Each universe developed its own laws, its own parameters, its own cosmic story. Some fizzled into darkness, others bloomed into galaxies. Ours became a place where atoms and starlight could form at all. And this is the unsettling part. Inflation predicts that these pockets, these bubble universes, are not rare exceptions. They are inevitable. They are countless. They are the default outcome of the physics that birthed our cosmos. If this is true, then the observable universe, the entire 93 billion light-year sphere we call everything, is just one bubble afloat in an infinite cosmic sea. It is strange to imagine that the edge of visibility, the horizon we call the boundary of our reality, is not the limit of existence. It is merely the curved inner surface of a bubble blown by the primordial forces of inflation. A membrane not of matter, but of reach. Light cannot cross it. Time cannot cross it. but gravity, in some forms, perhaps can. And beyond that membrane, the sea may stretch without end. NASA's observations have given us hints, faint, fragile, but mesmerizing, that something lies outside our bubble. The cosmic microwave background, that ancient glow from the moment the universe became transparent, is almost perfectly smooth. But almost is where the secrets live. Tiny wrinkles, slight temperature differences, small asymmetries. These have become the fingerprints of the early cosmos. Most of these wrinkles fit perfectly within inflation's predictions, but a few do not. One anomaly stands out like a bruise on the skin of the universe: the CMB cold spot, a region far colder than it should be. Too large, too deep, too improbable. Some argue it is merely a statistical fluke. Others say it might be the ghostly imprint of a void, a supervoid, in the distribution of nearby galaxies. But a bold possibility lingers at the edge of the data. Perhaps the cold spot is the scar of a collision between universes. Imagine two cosmic bubbles drifting through the inflating sea. Their edges expand, they swell, and just as soap bubbles sometimes do, they brush against each other. The contact leaves a mark, a distortion, a ring, a subtle change in the temperature of the cosmic microwave background. An ancient bruise left by another universe bumping into ours before drifting away forever. It sounds fantastical, but mathematically, physically, it is possible. More than possible. It may be expected. If inflation produces countless bubbles, collisions are inevitable. And if collisions are inevitable, their signatures might still echo through our sky. What would it mean to live inside a universe that once nudged against another? What would it mean if the cold spot, or other slight anisotropies, were whispers from outside our cosmic bubble? It would mean that the Big Bang was not the beginning of everything. It was the beginning of our bubble, a local event in a much larger structure, a spark in a sprawling cosmic forest. Inflation did not create one universe. It created a landscape of universes, a multiverse, not the fictional playground of science fiction, but a physical consequence of the mathematics describing the earliest moments of reality. In this landscape, each bubble is a world. Each world has its own constants, its own chemistry, its own possibilities. Some universes may have no stars. Some may expand too quickly for matter to ever form. Some may produce life stranger than anything we could imagine, and others may be nearly identical to ours. Parallel cosmic siblings drifting through the same inflationary ocean. NASA cannot see these bubbles directly. Light from them will never reach us. They lie beyond the cosmic horizon by definition, but their influence may bleed through. The patterns in the CMB, the large-scale alignments, the hints of asymmetry that should not exist in a perfectly uniform inflationary model. These may be the shadows cast from outside. The idea is intoxicating, terrifying, beautiful. If ours is one bubble, we are not alone. Not in the biological sense, but in the existential sense. Reality is not singular. Creation did not happen once. It happens endlessly, everywhere, forever. The multiverse becomes a cosmic rainforest, vibrant, wild, diverse, with each universe an ecosystem unto itself. But this expansion of scale does something strange to the human mind. It compresses us, shrinks us. We thought Earth was small when we discovered the solar system. We felt even smaller when we learned the solar system was one of hundreds of billions of stars, and smaller still when we learned the Milky Way was one galaxy among trillions. But the step from universe to multiverse is different. It is not a matter of size, it is a matter of meaning. If our universe is just one bubble among countless others, then our cosmic story is not unique. Our physics is not mandatory. Our existence is not inevitable. We are not a central chapter in the book of reality. We are one sentence in a library of infinite volumes. This realization can be crushing, but it is also liberating, because insignificance in scale does not equate to insignificance in meaning. Meaning is not granted by the size of the universe. It emerges from the act of witnessing it. And in a multiverse where most universes would be barren, silent, or chaotic, the fact that ours produced stars, chemistry, consciousness, and a species capable of asking what lies beyond becomes even more extraordinary. Perhaps rarity itself is a kind of destiny. Still, the philosophical vertigo is hard to resist. When we imagine our universe floating in an infinite inflationary sea, surrounded by bubbles we will never touch, never see, never confirm, we feel the distance between knowledge and truth widen. We feel the edge behind the edge, the hidden architecture of reality, looming like a silent cathedral beyond reach. What lies in the spaces between universes? What forces shape the sea in which they float? What landscape of quantum fields stretches beyond the boundary of our laws? These questions hover just outside our comprehension, like stars too faint to see but impossible to ignore. Inflation gives us a framework, but it does not give us closure. It opens a door to infinite possibilities and then locks it behind a veil of cosmic inaccessibility. We stand at the threshold, aware that the truth is vast but unable to cross into it. Yet the beauty lies in the attempt. NASA's instruments, scanning the ancient light, map the edges of our bubble. They reveal the subtle imperfections, the small asymmetries, the whispering hints that our universe was shaped by something older, larger, stranger. They give us the courage to imagine what lies beyond the veil. And slowly, as we piece together the clues, a profound image emerges. Our universe is not the entirety of existence. It is one chamber in a vast cathedral, one wave in an endless ocean, one breath in a cosmos that exhales universes like seeds scattering into the night. Inflation's hidden realms stretch beyond sight, beyond light, beyond the reach of time itself. They surround us in silence. They define us without ever touching us. They remind us that existence is deeper than understanding, and that the true architecture of reality may forever remain just beyond the horizon of thought. But the question lingers, soft yet immense. If our universe is only one bubble, what lies between the bubbles? For all the vastness we have explored, the galaxies, the horizons, the ancient light stretching back to the dawn of time, there comes a moment when the journey turns inward. A moment when the boundary we face is no longer made of distance, or darkness, or unreachable realms, but of something quieter, something softer, something human. Because as NASA stretches its instruments toward the farthest edges of the cosmos, another truth becomes clear. The final boundary may not lie in the universe at all. It may lie in us. We often imagine exploration as a conquest of space, a pushing outward, a reaching farther. But beneath that drive is something deeper, a longing not to escape the universe, but to understand our place within it. Every image from JWST, every map of the cosmic microwave background, every theory about inflation or the multiverse is ultimately a reflection, a mirror held up to the human mind, asking, why do we need to know? Why do we keep searching for an edge that always moves just out of reach? In a sense, the universe has been generous. It has allowed us to see 13.8 billion years into its past. It has offered clues about its birth, its shape, its fate. But it has also been silent, withholding the full truth behind horizons we can never cross. It reveals enough to awaken wonder, but not enough to grant closure. And in that tension, something profoundly human emerges. We are not just observers, we are meaning makers. The cosmos does not care about edges. It expands without intention. It evolves without purpose. It drifts toward entropy with no sadness or joy. But consciousness, fragile, improbable, temporary, looks at this indifferent expanse and asks questions anyway. The very act of wondering becomes an act of defiance against insignificance. Yet as we gaze deeper, a quiet paradox grows. The more we learn, the more unreachable truths we discover. Observing the universe changes us, shapes our understanding, but it also clarifies our limits. We cannot touch the cosmic horizon. We cannot see beyond the veil of inflation. We cannot witness other universes, if they exist at all. We stand in a vast cathedral of unreachable realms, holding instruments that whisper only fragments of the story. And yet, we search. Why? Perhaps because exploration is less about conquering distance and more about expanding meaning. The galaxies do not care that we study them. The black hole do not care that they terrify us. The cosmic web does not care that we map its filaments like veins of some unimaginable body. But in the act of observing them, we create significance. We turn silent structures into chapters of a narrative only minds can understand. NASA, then, becomes more than an agency of discovery. It becomes a metaphor for the human spirit, a symbol of our refusal to let the unknown remain untouched. Every telescope represents a question. Every mission represents hope. Every signal from the darkness represents a promise that even in a universe of unreachable realms, understanding is still possible. But there is another layer to this boundary, one not made of physics, but of perception. Every observation we make is filtered through the human mind, through neurons forged by evolution on a small, fragile world, through senses that were never designed to interpret the birth of space-time or the death of stars, through language too limited to hold infinity. And yet we try. We stretch our metaphors like tether lines across cosmic chasms. We build theories like ladders reaching upward into the dark. Still, the question lingers. How much of the universe is shaped by what we see, and how much is shaped by what we can see? What if the final edge is not the horizon of light, but the horizon of comprehension? For even if we could observe everything, would our minds be capable of grasping it? Or would the truth overwhelm us? Too vast, too complex, too alien for meaning to survive the encounter. As scientists confront phenomena like dark flow, early galaxies that should not exist, or the ghostly possibility of other universes, they are also confronting this deeper boundary. The universe is not just bigger than we imagined. It is stranger than we can imagine. And so, we stand at the border between the knowable and the unknowable, aware that some mysteries may forever remain outside the reach of thought. Yet there is something beautiful in this limitation. Because meaning does not come from knowing everything. It comes from the pursuit itself, the quiet courage of looking into the dark and asking for more. Curiosity becomes its own form of illumination. Wonder becomes a bridge across the gaps we cannot cross. Ignorance becomes not a flaw, but a catalyst. In this sense, the universe's greatest gift is not its answers, it is its silence, its refusal to be fully known, its endless horizons that draw us forward, generation after generation, into deeper levels of insight and humility. The unreachable becomes the invitation. And through this invitation, something unexpected emerges. The boundary between cosmos and mind begins to blur. The universe, vast and indifferent, becomes meaningful only because consciousness witnesses it. And consciousness, fleeting and fragile, becomes profound because the universe calls it to awaken. We are shaped by the stars we study. Our thoughts are shadows cast by ancient light. Our questions are echoes of cosmic events older than our world. The boundary between self and cosmos becomes thinner than we ever realized. In this act of mutual definition, a new kind of edge appears. Not physical, not scientific, but philosophical. It is the boundary between what the universe reveals and what it forever hides. Between the truths made visible by light and the truths concealed by horizon, by inflation, by the limitations of mind. Between the stories written in the sky and the stories we must write for ourselves. And this final boundary is different from all others. It is not a wall we can observe, or map, or detect. It is a boundary made of longing, of curiosity, of the quiet ache to understand what cannot be touched. NASA's telescopes may look outward, but their discoveries ultimately turn us inward, toward the mystery of why we need to see at all. Why a species so small insists on reaching for truths so large. Why meaning flourishes not where knowledge is complete, but where it ends. Perhaps this is the real cosmic horizon. Not the edge of space, but the edge of interpretation. The line where observation fades and imagination begins. The place where science meets philosophy, and where the universe hands its narrative to consciousness to finish. We stand there now, at the final boundary, a place not of endings, but of quiet understanding. We will never see beyond every horizon. We will never know every realm. But maybe that was never the point. Maybe the purpose of intelligence is not to conquer infinity, but to illuminate a small part of it with awareness. And in the calm after awe, in the silence after wonder, a gentle realization settles. Perhaps the real edge is the boundary between what the universe reveals and what it forever hides. In the end, after all the distances measured, after all the ancient light gathered, after every paradox stretched to its breaking point, NASA discovered something profound at the edge of everything, but it was not what anyone expected. It was not a wall, not a boundary, not a fracture in space-time or a cosmic curtain beyond which nothing exists. What NASA found was something quieter, something deeper, something that has been hiding in plain sight since the first time a human being looked at the stars and wondered what lay beyond them. It found a limit of us. The journey began with a simple contradiction. The universe has no edges, yet we see one. The cosmic horizon stands before us like a distant shore, shimmering with the light of a universe long gone. It is not a barrier imposed by the cosmos, but by time itself. A horizon we cannot cross because the light beyond it has not yet arrived. But as NASA pushed deeper into that horizon, something unexpected happened. The universe began pushing back. Early galaxies appeared that should not exist. Structures too large for their age materialized like silent accusations against our models. Supermassive black holes awakened far too early, as if the universe itself had skipped chapters in its own evolution. And subtle fingerprints, anomalies in the cosmic microwave background, signs of dark flow, hinted at forces lurking beyond the boundaries of our observable bubble. Every discovery strained the frame of our understanding. Every new observation forced theory to stretch, to bend, to tremble. It felt as though the cosmos was not just a place to explore, but a mirror held up to the limitations of human comprehension. We expected the universe to be orderly, predictable, obedient to the rules we wrote for it, but the deeper NASA looked, the more the cosmos whispered a truth we were reluctant to hear. The universe is under no obligation to make sense to us. The edge of everything, it turns out, is not a location. It is a confrontation between what is real and what the mind can contain. As JWS gazed back in time, revealing galaxies that should not exist, we felt the quiet tremor of that confrontation. Physics models strained, experts debated, theories wavered under the weight of impossibility, and yet the galaxies existed all the same, shining defiantly across billions of years. They were not wrong. Our understanding was. Dark flow brought another shock. Thousands of galaxy clusters seemed to be moving together, pulled by something outside the observable universe, a force we cannot see, cannot measure, cannot name. If the cosmos beyond our horizon holds structures so vast they influence the motion of galaxies here, then our universe is not the entire story. It is a chapter, a region, a bubble, adrift in an infinite inflationary sea. Inflation itself carried the final blow. The idea that our universe is only one pocket in a vast cosmic landscape. One bubble among countless bubbles, each born from the same quantum fire. And if that is true, then the edge of our universe is not an edge at all. It is simply where our bubble stops being visible, a horizon painted by light, not by existence. Beyond it, reality continues without pause. NASA did not discover the limits of the universe. It discovered the limits of our reach, and that realization changes everything. Because for centuries, we believed that exploration meant expanding outward, charting new continents, mapping new oceans, landing on new worlds. But cosmic exploration is different. Out there, the distances grow faster than we can chase them. The horizons recede faster than we can approach. The universe accelerates away from us, stretching space itself like fabric pulled too tightly. We are not chasing a distant shore. We are watching the shore drift away. And yet NASA continues to look. Not because we expect to find the final answer, but because the act of looking reshapes the way we understand ourselves. Every telescope becomes a philosophical instrument as much as a scientific one. Every anomaly becomes an invitation to humility. Every horizon becomes a reminder that our place in the cosmos is not defined by scale, but by perspective. We are small, astonishingly small, and yet capable of contemplating the vastness that dwarfs us. That ability is its own form of greatness. At the edge of everything, we do not find a final truth. We find a challenge to keep expanding our understanding, even when the universe refuses to reveal all of itself. To accept that the cosmos will always exceed our comprehension, and yet still reach for meaning within it. This is the synthesis, the grand revelation. The cosmic horizon showed us the limit of light. Early galaxies showed us the limit of prediction. Dark flow showed us the limit of gravitational influence. Inflation showed us the limit of our reality itself. Four boundaries, four edges, none of them physical, all of them conceptual. The universe does not end where light stops. Our vision does. The universe does not break where theory falters. Our assumptions do. The universe does not fracture at the horizon. Our comprehension does. The edge is not a place. The edge is an encounter with everything we do not yet understand. This realization does not diminish us. It elevates us. Because in a cosmos where universes multiply endlessly, where inflation births worlds we will never touch, where unseen forces tug at galaxies across unreachable distances, the very fact that we can even conceive of these ideas is extraordinary. We are creatures of dust, born in the glow of a single star, occupying a tiny planet in an unremarkable corner of a galaxy. And yet we are capable of constructing telescopes that stare into the dawn of time. We are capable of recognizing patterns in ancient radiation that hint at realities beyond our universe. We are capable of asking questions that stretch not just across space, but across existence itself. The edge of everything is not a barrier the universe imposes on us. It is a boundary we cross every time we dare to ask a question it cannot fully answer. Understanding this transforms the cosmos from a riddle into a relationship, a conversation. The universe offers clues. We offer interpretation. The universe offers silence. We offer imagination. The universe offers horizons. We offer the willingness to walk toward them, knowing we will never reach their end. And maybe that is the point. If the universe revealed everything at once, the story would end. Mystery would collapse, wonder would evaporate. But by withholding its deepest truths, the universe keeps us moving, thinking, dreaming. It demands that we grow into the questions we ask. At the edge of everything, NASA did not find emptiness. It found meaning, not because meaning is carved into the stars, but because meaning arises from the very act of looking at them. When we stand beneath the night sky, we are not witnessing the universe from the outside. We are participating in it. Our questions become part of its structure. Our curiosity becomes part of its evolution. Consciousness becomes an extension of cosmic history. The universe waking up to see itself in fragments. And so the edge becomes a beginning, not an end. A place where our knowledge fades into possibility. A place where science meets philosophy. A place where the human spirit meets the immensity of existence. Perhaps, then, the true revelation is this. The universe is not a puzzle to be solved. It is a horizon to be approached endlessly, joyfully, humbly. And the edge of everything is not what we find out there. It is what awakens in us when we dare to look. In that serenity, the cosmos settles into clarity. The mysteries remain, but they no longer feel like failures of understanding. They feel like invitations. And as the narrative draws to a close, a final thought settles like starlight across the mind. Perhaps the edge is not where the universe ends, but where our understanding begins. In the end, after all the distances measured and all the horizons traced, we return to where we began, to the quiet question that first stirred beneath the stars. What is an edge in a universe without walls? What is a horizon in a reality that never truly ends? The farther NASA looked, the clearer the answer became. Every boundary we discovered was not a limit of the cosmos, but a threshold of understanding. A place where knowledge fades into wonder, and wonder softens into silence. We began in nothing, in the darkness before light learned to move, before space learned to stretch. From that silence emerged everything: galaxies, stars, consciousness, questions. And each question led us outward, until the universe felt less like an expanse and more like a mirror. A horizon that does not recede, but reflects. A boundary that watches us as closely as we watch it. Because the cosmos, in all its immensity, reveals itself layer by layer. Every discovery uncovers a deeper mystery. Every solution opens a new door. We chase the edge, only to find it slipping forward, inviting us to follow, not to reach an end, but to grow into the questions we ask. And maybe this is the quiet gift the universe offers. Not certainty, but invitation. Not answers, but perspective. The realization that the journey is not toward the edge of space, but toward a deeper understanding of our place within it. We stand beneath the stars, small yet aware, fragile yet curious, brief yet capable of contemplating the infinite. In that awareness, something profound unfolds. A serenity born not from knowing everything, but from accepting that we never will. The universe may not have an edge, but every horizon brings us closer to understanding who we are.